Hi everyone. Hi Winda. How are you? Apa khabar?
Hi, Joy. Thank you. I'm all good. How are you?
I'm good. I'm good. Thanks for asking. Awesome. Let's get started. Hi everyone, and welcome to the Google Developer Space channel. I'm Joey, and this here is Winda from GoJakarta. We hope everyone is doing well and keeping safe. So do give yourself a shout out on our live chat and comment section to let us know where are you tuning in from. I think today we have a lot of folks tuning in from Singapore and also Indonesia, hopefully everywhere else around the world as well. Before we begin, let me briefly introduce what we do and who we are. So Google Developer Space is a platform for developers and startups from around the region to learn, connect, engage, and be inspired. As part of the developer relations team, we aim to empower and connect the community to our people, program, networks, and technology, be it in person or online like today. And today, for the very first time, we are hosting Go Jakarta's meetup. I believe Winda has prepared an amazing agenda for everyone. So without further ado, I'd like to hand the time over to you, Winda.
Thank you, Joey. Hi, everyone. Thank you so much for joining us on our live stream for GoJakarta. And we have two speakers here, so I will explain a bit about our speakers. We have Hamza Ali. He is a Go programmer, and he will share about WebSockets in Go, covering building WebSocket application with Go. And Kenneth the CTO of Brankas, will share dynamic GraphQL with Go, detailing the different methods and techniques for using graphic QL with Go. So I think we will just move to our first speaker, Hamza. I will uh, I will read his detailed profile here. Hamza Ali will share WebSockets in Go, detailing his experience building WebSocket application with Go. Hamza is early in his career as a web developer and is a student of all things pertaining to programming, Go, uh, and the internet. During this talk, Hamza will cover the basic of building bidirectional WebSockets between servers and clients in Go. Additionally, Hamza will give a live demonstration of a basic chat application running in the browser using plain JavaScript without frameworks and interacting with a Go application. Hamza has been programming for 6 years and has extensive development experience with Java, Kotlin, Go, and Elm. Hamza, when he's not studying technology, he's building web applications and writing automation testing suites. Hamza is a frequent community contributor, having previously presented to Go Jakarta and others. Presented in English. Okay, so
Wow, sounds
uh,
amazing. Let's bring Hamza on the stage.
yeah, sure. Okay, so here we go. We will add Ham here.
Hi, Hamza.
Yeah.
Hi, Joe. Hi,
So
Winda.
we've just added your
Hello,
screen.
Hamza.
The stage is yours. We'll let you go ahead with your presentation, and Winda will pop back in during the Q&A session.
Sounds good. Hi,
Okay, see you
everyone.
then.
Hi, everyone. My name is Hamza, and I am a student in Jakarta Intercultural School. I am graduating in 2022, and I've been programming in Go for almost 2 years now. Today, I'm going to be talking about the basics of Go and WebSockets. So why WebSockets? Well, before I can answer that question, I need to give a little bit of a basic on HTTP for those who might not know. So in the world of HTTP, we have the browser and the server. The browser requests information from the server, and the server can process that request and then give a response. So when the browser gives a request, it gives contextual information, like what kind of information it needs and information to identify itself. And then the server can process it, and they can either give back the data that they want, or they can even say that I don't have this data, or that you're not authenticated to receive this data. HTTP is a protocol where you have data sent to you upon request. If the server gets new information and wants to send it to the client, it has no way of letting them know unless the client asks for it first. This was fine when the web was originally created a few decades ago, where we had single-page HTML documents where everybody could just load it once and interact. But now in the modern web, this is not ideal anymore, because how would you make things like social feeds, where if you go to Twitter or Instagram, you automatically have comments and likes updating, or make like chatting applications such as Discord or Slack. You can't make collaboration suites like Google Drive or OneDrive. Data streams for like web, like online chatting with a video or just like sensor data is not possible either. And making games run in the browser is just impractical because there's no way to transfer data in real time. So what are WebSockets? One definition I often use to describe WebSockets is a protocol for communication, a real-time communication between the browser and the server. So how do WebSockets work? So in WebSockets, there is no need for data upon request. Instead, what happens is that the browser first initializes a connection with the server. After that happens, both are free to send data back and forth whenever they wish. And there is no time limit, and it can be either the server or the client. No need for a ping pong. So the server can send data foo to the server to the client, and the server can also send data once more, such as bar. So under the hood, WebSockets are similar to HTTP, but have a few differences. Firstly, all of the requests have an upgrade header that let the server know that I want to convert this request into a WebSocket one. They keep the TCP connection that was established by the HTTP alive and use that to communicate data. Instead of using HTTP, you use the WS protocol, and each of the data that is sent back and forth is known as messages. The messages are made up of multiple frames, which can be really good when you're working with larger messages like video data, so that they can be broken down and sent more efficiently. There are a couple of alternatives like server-side events. If the server gets info, though, it has to wait until, so with server-side events, unfortunately, it has only unidirectional data, so only the server can send data to the client. There's no way for the client to send data back to the server. This can also be, there's also another problem where the server does not know if the client disconnects and only finds out when they try to send a request and it fails. HTTP long polling, on the other end, has the functionality for data to be sent both back and forth, but unfortunately, it can be a lot more intensive on the server and take up a lot more bandwidth as well. So now I'm going to go over the basic server-side implementation of WebSockets. For this, we're first going to create a basic HTTP application just to know where we're getting started. So over here, we have the verify endpoint. And whenever that is called, we have this index handler function that will be called. Here, we can see that we just take the writer to the response and write hello world to it. Once we have that set up, we just start up the server and listen for any incoming requests on port 8080. We can test this using a basic curl client, and we can see that when we send a request to 8080 and the endpoint of verify, we get the information back of hello world. Now we're going to talk about how we can handle requests to WebSockets and how we can deal with them as a server. For WebSockets, I actually chose not to use the standard library and instead chose to use Gorilla's WebSocket library. It has many features that the standard library doesn't, and it's also, in my opinion, much easier to interface with, so you have a much better development experience. So here we have the basic setup for accepting incoming connections to a WebSocket client. We can see that we have a basic function setup where every time that we receive a request, we have data of the request, which is in the second parameter, as well as a way to send data back using the response writer. But we also need some extra setup, and WebSocket upgrader. Basically, the role of this is to convert the connection from a regular HTTP request into one that can be used for WebSocket communication. We also can configure a few settings, and those are a little bit more advanced, and I just set the maximum read and write sizes to 1 kilobyte. Next, when we receive a request, we want to first convert that connection into a WebSocket 1. So here we give it both parameters, and we go ahead and upgrade the connection. But this has a possibility to fail. For example, let's say that the client decided to not actually send a WebSocket request and just a basic HTTP request. In that scenario, we can go ahead and let them know that there was a connection error. This can also happen if the client doesn't support WebSockets, and that is just, we just deal with that. Next, we will move on to dealing with the implementation of receiving messages from the client, as well as disconnection. So here we added a for loop as well as a close method that will help clean things up for us. But before we cover that, let's go ahead and remove the stuff that we've already covered. The first thing that we do is we use a defer statement with the close method. Basically, this just lets the the WebSocket client know that once we are done with this function, to close the connection for us. The defer makes it so that even if we have a return statement early on, we don't have to explicitly close it, and we just know for sure that it will close regardless. Next, we move on to this for loop. We are not sure how many messages the clients will send or if they will send any at all. So we just have an infinite loop where we keep receiving messages and dealing with them as they come. So we use this ws.readMessage to wait until either the client gives us a message or if there's an error. If we are to receive a message, the first parameter is of the type of the message. Most commonly, it's either a text one or a binary one, but it can also be a ping pong message to make sure that both the client and the server are responding to each other. And it doesn't time out. It's similar to like a heartbeat. Next, we move on to the last parameter, the error. And basically, this will not be nil, meaning that there was some error, most likely when the connection is disconnected from the client. And so basically, when that happens, we have another lifecycle event where we have disconnected from the client, and we can handle that however our application needs to. Next, we convert the message that is initially in bytes over to a string so that it's easier for us to handle. And then we can do our third lifecycle event of handling it however our application needs us to do. So here I have designed a simple echo server. And basically how this works is that whenever we receive a message from the client, we just send it back to them. And so the only thing that's new here is that instead of us handling disconnection and connection in a separate function, we just break out of the code. And whenever we receive a message, we just send it back using ws.writeMessage. Now we can use our basic WebSocket tester to check it out. So here, when we send them hello, the server sends us back hello. And it's the same for when we write 1, 2, 3, and for so on and so on for anything that we send to the server. Now we're going to look at the basics of doing this in the client. And so in the client, there is also 3 lifecycle events. The first one is, but before we do that, we need to first establish the connection. To do that, we just create a new WebSocket type using the DOM API that the JavaScript has available in the browser. We give it the location that we want to connect to, and we let it deal with the rest. The first lifecycle event that we have is onOpen. This is when the server receives our request, acknowledges it, and then finally agrees to open a WebSocket connection if everything went well. Here we can do all of our logic to make sure to like start up our chat application that we're going to be doing, or a number of any other things. The next one we have is onMessage. As its name says, it's called every time that the WebSocket server sends us over a message. We can then go ahead and handle it however we wish in this lifecycle event. Finally, we have our close method. This will be called either when the client decides, the client decide to close it, or if the server goes ahead and closes the connection as well. Finally, we have one way to send data back over to the server using the send method available on the WebSocket. Now, I will move on to our basic demo for this chatting application. So the first thing that we're doing is that I just have a basic WebSocket server running in the background. And we can go ahead and see here that we have a little bit of markup to create our chatting application. The first thing that we need is for us to register ourselves. So I can go ahead and type in my name to enter the server. The first thing that we see is that our name was added to the online users. We can type hello, and we get our message saying that we have said hello. If I go ahead and copy this and create a new tab, it will go ahead and allow us to enter another name. I'll go ahead and add Hamza too. And now both of us are connected, and we can see that in our online users. We can go ahead and say, hey, here, and we can see that over in our first one, we get the message saying, hey. Now let's go ahead and take a look at our basic implementation. So here is the basic structure of our application. We have the main.go, where we will be handling creating the WebSocket as well as the HTTP server. We have our hub, which will be mostly handling WebSocket lifecycle events, like when we receive a message, when somebody joins or disconnects. And then we have a static server that will be sharing over our HTML, CSS, and JavaScript files. Let's go ahead and first take a look at our main.go file. So here we can see that if we go ahead and look at our main function, that we have two handlers. The first one handles our /WebSocket endpoint, and this will go ahead and manage our WebSocket connections. The second one that I haven't covered yet is this file server. And basically what it does is that whatever we have in our static directory here, it will go ahead and display it if on the /path. So if I go ahead and click this file, we can see, if we look at our file structure, that we have this verify.txt. If we go ahead and look at its contents, we can see that it contains hello world. If you go ahead and go to our browser, we can make sure that everything is working fine if we go to /verify.txt. And as we can see, that everything is fine, and it shows us hello world. Now, if we go back to our command line, we can go ahead and take a look at how our HTML file is structured. So when we start off, we have our basic head elements, and then we have a snack bar. This snack bar I'll cover more in later, but it's used to handle errors and whatnot. And then we have a modal that we use to enter our username. And then we have our basic chat container, where we have our input to send messages, as well as our online users. Now we can go ahead and take a look at our server implementation. So if we go ahead and go to main.go, we can see here that we have a similar upgrader defined as we saw in our slides. We go ahead and use that to first upgrade the connection over to a WebSocket one. And we let the server know if there was some error in doing. We let the client know if there was some error in doing so. Finally, we add our defer statement so that the server knows that once we've stopped dealing with the WebSockets, that we can go ahead and close the WebSocket connection. Next, we ignore the message type of the server because we handle all of them as plain text. We go ahead and read a message. If there was an error doing so, we assume it to be a disconnection, and we handle it in our WebSocket handler. And we do the same for when we successfully receive a message and want to handle it. If we now go ahead and go over to our hub file, where we can see our WebSocket implementation. So the first thing that we can see is our handle incoming message function. And here, what we first do is, so how our application works is that we have two states for all users. Either the user is registered and is receiving chat messages to communicate with everyone else on the server, or is registering. And when they are in the registering state, the first message that they send to the server will be their username. And so the first thing that we do on line 14 here is we let the server know that if their connection is in this map. In this map, we have a key of value set of the connection ID and all of the information regarding that specific connection, as well as their username. And once they register themselves, they're added to this map. And then we also have a map of the inverse so that we make sure that people don't register with the same username. The first thing that we do is we see if they're already in our map, that means that they're trying to chat with the server. And we go ahead and handle that in our chat message function. Otherwise, we have our little snippet to go ahead and register the user. Now, we have defined a few illegal usernames if it's nothing, or if the username is server, because we use that to let the client know for any lifecycle events. We go ahead and tell them that there was an error if they have an illegal username. And we do the same if their username has already been taken, if it's present in our name to connection map. Finally, we go ahead and send them our list of online users. And then we add them over to our, and we go ahead and register them to the server. Finally, we go ahead and dispatch a server to let all of the clients know that a new user has joined. Now for our disconnection handler. We have two states here as well. If they have disconnected without registering, in which case we just disconnect and do nothing. Or if they are already registered, in which case we go ahead and do a new message. We create a new message and dispatch it to everyone, where we let everyone know that this user has disconnected. And then we also remove them from our maps so that their username becomes free to use for everyone. Our server communicates using 5 different message types. We have the message where it's like a chat message. We have when people join or leave. We have one where there's an error in some action that the user is trying to do, and when we're trying to send the list of users available. We encode all of our messages in JSON because that's really easy to work with on the client side as well as with Go. And we have all of the information that will always be sent in the similar type of JSON structure. We have the message type, which will be one of the 5 that we've covered, the sender of the message, and if the server is sending it, we use the string server, the content of the information, which can be anything, but when it's a chat message, it's a string. We have the date of the message so that it can be synchronized between people on different time zones. And then we have whether or not it was a successful message or if it was trying to report an error. We have a utility function here called new error, where it quickly creates a structure for us, setting all of the values that we don't really worry about. When we receive a message that wants to be broadcasted, a chat message, we go ahead and use the function send chat message. Over here, we use the message chat type for the message. We go ahead and use their username and the content of the message, and then we go ahead and dispatch. Our dispatch function, which is defined on line 90, goes ahead and goes to all of our registered users and sends them the message. That's mostly it for the server. There's a few things that I didn't cover, and I'll make my code available if you guys want to inspect it more closely. Next, I will go over the basics of how we have implemented the server over on the client side. The first thing that we do is we define all of the elements that we are using, and we store their last used username in local storage just for a little bit better of a user experience. We go ahead and dissect the URL to get our WebSocket connection. So WebSockets also have a secure implementation known as WSS. And we use that if the client is connected to a HTTPS. And otherwise, we just use the WebSocket protocol. We go ahead and use the host. So even if we're not working on localhost, you can connect over to our server using HT. You can use it using any domain or URL. Then we go ahead and create our WebSocket connection using the new WebSocket constructor that we covered in our slides. When we go ahead and have our connection open, we then go ahead and show our modal where they can select their username to communicate. When we receive a message from the server, it can be one of the 5 lifecycle events, one of the 5 events that we defined on the server. It can either be a chat message, a join message, a leave message, a user list, or an error. So we first check if it's, we first convert it into JSON so that we can easily read the data through it, and we check if it's an error. If it's some sort of error, we go ahead and show it over in the snack bar. Next, we check if the user is registered or not. If they aren't registered and there wasn't an error, then we can assume that they have now successfully been registered. We go ahead and store their username in our local storage. We hide our modal. We focus the chat, and we know that the first message that we receive when they are added to when they're registered is the current online users. We go ahead and go through all of the ones that are online, and we add them over to our side panel. Otherwise, we know that the message that we received is a chat message sent to us by either ourselves or somebody else on the server. So we have mainly 3 types of messages that we can deal with now, as we've already dealt with the user list one and the error one. And if it's a join one, we go ahead and add them to the side panel as well. And if they're leaving, we do the opposite and get rid of them. Finally, we have our chat message function where we are able to display it over on our chat. Here, we can see that we have all of the information for creating the chat, the chat elements and adding them over to our panel where all of the messages are available. We go ahead and take the information, and then we form an element and go ahead and append it. And so that's mostly the gist of how this WebSocket server works. And we can see that the 3 main lifecycle events that we deal with are disconnection, connection, and receiving messages. So this project that I created is not very complicated and doesn't go too much into depth. And there's quite a few ways that you guys can extend this if you would like, and do some exercises to make sure that you understand how all of this works. So if you want to take it to a new level, the first thing that you can do is that you can store the messages that the server has received, and whenever a new client joins, you can go ahead and send them to the new clients as well, and so that they can see a little bit of the history. If you want, you can also make it so that you store all of the messages since the beginning of time, so that they can see everything. You can also make it so that people have to authenticate themselves. So perhaps that would mean having a username and a password, and having some sort of database that you connect with. And finally, you can also add support for editing messages and deleting them, which would require you to store information about the messages so that you know that only the right person is able to delete or edit them. And so that's mostly the basics of using WebSockets with Go. And here's a little bit more information about myself and about the project. If you want to see more information and the documentation on our WebSocket client, you can go ahead and find it on GitHub at gorilla/WebSocket. If you want to find more information about WebSockets and with JavaScript, you can go ahead and go to this link to read up more in depth about it. If you want to get in contact with me, you can find me at my email, and the slides and the source code for this demo is available at my website at this link.
Okay, Hamza. So all the presentation is done. So
Yep.
we just jump into the Q&A session now.
Yep, that's good. That sounds good to me.
All right, so we already have some questions here for you, and then actually it's some answered by Ken, but maybe you have a different point of view for the answer. So I just show the question now, so maybe you can answer. This is a question from Muhammad Gifari Yusuf. My company have multi-servers and use WebSocket from live chatting, game, quiz, etc. How to handle if a user send WebSocket and want to send across servers? For now, I am using Redis PubSub.
So for this, I would most likely recommend is that you have one central server, and that central server then receives all of the WebSocket connections, and then you can go ahead and path that over to each of your specific microservice or particular service, and then handle them however you wish. That's if you want to keep only a single WebSocket connection. You can also just have a separate WebSocket connection for each one of your services and have each user connect to them manually. There's no limit on how many parallel WebSocket connections you can have at a single time, but on IE 9, which came out almost a decade ago, it is limited to 6.
Okay, so another question. It's the continue actually. Do you have best practice and suggest for my case?
It's going to be a little bit difficult to give you a particular best practice because it's going to depend a lot on how many clients you have at a single time. But I'd say that the best bet would mostly be for you to have a separate WebSocket for each service and handle them each separately.
All right. So I hope that's clear for Muhammad Gifar Yusuf. Also, let's jump into another question. It's from, let me show you here. It's from Gary Almas Samaita. How to perform load tests on WebSocket to measure performance in handling multiple concurrency.
So under the hood, WebSockets all have their own individual coroutines. And so you could probably do some time management to see when a request was made and when the message, when the responses, the messages sent back, if you're doing something like that. But you can also use Go's tools. I think it's called proc tools or something like that, and you can use that to see how the CPU usage is, to see if you need to make your client server implementation more efficient.
Okay. So it's still from Gary Almas. How to scale WebSocket with multiple instances?
So honestly, the one disadvantage with WebSockets is scalability. It can be a little bit of a headache as you have to have a real-time communication. And honestly, I could spend another hour just talking about that. I'm free to give you some resources if you go ahead and email me, and I'll get in touch with you on how you can get more particular in scaling WebSockets, because it's not a simple task.
So, okay. I hope it answer your question, Gary Almas. Please wait. I think we still have another question. It's from Ahmad Hafiz. How to perform testing on WebSocket?
So the current library that I'm using, I'm not aware if it has any testing capabilities. But in the past, when I've wanted to write tests with WebSockets, my general goal is to just test the input and the output using a WebSocket client and just do like an integration test.
Okay. Do you want to add something, Hamza?
I see one more message from Hazik Haikal.
What?
I think that we can bring it up and we can discuss that.
Wait. Let me search it. Hazik. Oh, okay. How do you handle real-time data stream? Yeah, please.
So generally, when I want to do something like this, what I would do is I would have a write pump. There's a great example available in the GitHub repository with, I think it's the Echo example. And over there, what they do is that they have all of the messages that they want to dispatch in a pump, and they just send them over in their own coroutines, and that helps make sure that like if there's some slowdown with the client, it stays smooth for everyone else.
Okay. We still have another question from Hazik Faikal. Do you use stickers send it on specific interval?
That is possible, but if you would like, you can also just send it as you get. And if you have a lot of data that is sent or like in packages, using a ticker is, in my opinion, a fair solution.
Okay. We still have another one here. Do you have tips in handling auto downscale of WebSocket servers to ensure that currently connected users won't be disconnected abruptly?
In those scenarios, I haven't had any personal experience with downscaling WebSockets, so I can't speak from particular experience. But what I would think is what you should do is you should have your WebSocket client be in such a way so that handling disconnections is possible, because you have to remember that even if your client like sleeps their laptop or anything, the connection is automatically closed, and you have to reconnect anyways.
Okay. Do you guys still have any more questions for Hamza? Please right here. Or Hamza, do you have any additional points do you want to share or something?
Sure. So building on the last question that Roland asked, I would like to mention that when you're working with WebSockets, there is no automatic reconnection, and that you should implement that yourself. And I think that that's a good thing, because you can be more explicit with how you want your reconnection to work and mesh with your application. And yeah, so one last thing is that I would really recommend you guys that when you're working with WebSockets, to keep both sides stateless, and to just reconnect it via communication. Because with WebSockets, it's easy for the client to get disconnected, whether by just closing their device. And so having to have a lot of contextual information that the server expects or the client expects can make your WebSocket implementation a bit more confusing.
Nice. Any more question for Hamza before we move on to Ken's presentation? No. All right. So Hamza, thank you so much for the presentation. It's really nice.
Yeah,
So
thank you everyone for
we're
tuning
going
in.
Yeah, thank you, Hamza. So we're going to move to Ken. Let me read his profile a bit in detail. Okay. So Kenneth Show will share GraphQL with Go, detailing ways to dynamically work with GraphQL in Go. Ken is the former CTO of multiply.com and the founder and CTO of Brankas. During this talk, we'll detail multiple methods available of working with GraphQL and Go, including covering dynamic query introspection, schema generation, and do a short tour of the devices that are available to the Go community. Ken has spent the last 16 years building highly scalable payment and transaction systems using a variety of programming languages and frameworks. Ken is the author of a number of popular Go packages, ChromeDB, XO, and USQL, and has been actively programming in Go since late 2012, presented in English. Okay, so I will add Ken here. Okay. Hi, Ken, can you hear me?
Hi. How's it going? Good evening, everyone.
Hi. Yeah. All good. Thanks. Hi, everyone. Yeah, so Ken, you can start the presentation now. So I will add your presentation screen here now. Okay.
Awesome. Okay. So my presentation tonight is on dynamic GraphQL with Go. So first, I just want to give a big thanks to Google Developer Space for hosting the event. And also, if you're not already a member of our groups, we've got a meetup group, a Telegram group, a Facebook group, and others. So by the way, if anybody says anything, I'm not going to hear it because I have like a delayed echo in my headphones. Sorry. All right, cool. So basically, if you're not aware of what GoJakarta is, GoJakarta is a monthly meetup focused on the Go programming language, but we also incorporate other topics related to Go, such as deploying Go apps on the cloud. So we're always looking for presenters, so please contact me or Winda. This is our contact info. I think it's also shared maybe in the video description or some such. Or if not, just join our groups and we're there. The next meetup, we're going to be doing something with GoKL and Go Singapore maybe later this month. We'll share the details when that's available. Real quick, my company Brankas is hiring, so for all kind of technical positions, just solution architects, engineering managers, back-end, front-end, site reliability engineers, etc. So if you're technical or technically oriented, please send your CV, careers at Brankas. These slides are available online. Just do a go get -u gophers.id/slides. All right, so just want to get into it. So if you're not aware of what GraphQL is, it's a query language that is designed, quote unquote, for your API. That's the silly description from the GraphQL.org website. It was initially built by Facebook in 2015, and it basically allows clients to dynamically build and send queries in a way that's meant to be forwards and backwards compatible and independent of the client's needs to format, model, or present the retrieved data. GraphQL is designed so that it kind of solves the problems of both mobile and web apps. And you'll see why that is in the syntax in the next couple slides. But what's really great about it is that it really reduces, possibly eliminates the round trips to backend, so you can kind of get all of your data in one single request. So when you're dealing with mobile apps and you're dealing with, latency that's introduced from mobile networks, this is where GraphQL can be very useful. What's really good though is it really allows development teams to move faster because it creates a highly decoupled front end from the back end. Typically, if you've ever done some very heavy UI intensive applications, basically what it has to happen is that when a new feature or something needs to get introduced, there has to be some implementation done by the back end. What it allows, though, what GraphQL can now allow or enable, at least when used properly in a development organization, is to essentially be able to send queries or build queries in a client and not have to have any knowledge of how that backend is or how you connect to it or any of that kind of interesting information. So just to give you an overview, this is what GraphQL looks like. So this is a simple GraphQL schema. This is taken directly from the GraphQL homepage. What you can see here is that you've got, you'd have a type declaration. If you notice, the syntax here is very similar to Go, which is one of the reasons why I kind of like GraphQL. I'm not exactly a big user of it, but I can appreciate its utility for certain situations, even if my company or my development doesn't necessarily intersect with it. But you basically have, your field names, you've got a type, and then, you've got, for example, here, contributors. This would basically be an array or this specifically, it's a JavaScript array because the responses actually come back as JSON formatted data. So it's a JSON array, right? The reason for that the data comes back formatted in JSON is so that it's easily consumable by web clients or in web applications. So given that very simple schema, and there are a lot of other extensions to schemas. You can declare separate queries, you can declare mutations, you have interfaces, you have a whole wide variety of kind of modern things that you don't find in other syntax languages like SQL or others that allow you to basically create very composable graph queries in a way like this. And ultimately, what it kind of comes down to is you end up building a query that looks like the above box, which is you basically query the actual field or the name. You have a parameter. In this one, it happens to be name. That was declared back here. It's basically declared by your type. So you can essentially query, typically in a GraphQL query, you can query any of the fields. And unlike, let's say, SQL, which has a lot of different types, GraphQL really only has a few built-in types. So string, integer, ID, and a few others, which are, and basically objects. Because there's really trying to be a one-to-one mapping to JSON. So you're essentially limited to the types that you have inside of JSON, which are objects, arrays, strings, and then numbers, which is really all that JSON has. And that's really kind of what you point out here is that you query for the fields, possibly the subfields, and then that comes back to you in the query. And you get this one-to-one mapping in the JSON response, which is shown here between, for example, project, tagline, etc. And then this is in your graph query, i.e. what's here on the above. For the way it works is that it essentially traverses a graph store, or at least something that represents a graph store or can be represented as a graph store. And you traverse the edges essentially until you get to your end nodes. And then the end nodes are the values that are returned for that. So for example, in this, you have an edge named project in your type, which is the project type, right? And then you're essentially then traversing and asking for the tagline. When it has a terminating node, then it returns that data, that set of data, which is here that a query language for APIs. This just give you a very simple example of how this works. Now, this is not too fundamentally different from, let's say, REST or other RPC mechanisms such as gRPC, etc. It's just different. And I really want to emphasize that there isn't really a lot that there isn't necessarily one way versus the other, i.e. using REST or using this. And in fact, if you go back to the kind of the history around GraphQL, Facebook originally built it to facilitate greater, graph style queries on existing REST-based APIs. So they can coexist and live in the same world. What really it does is it kind of decouples the direct, let's say, socket by which, and I don't mean TCP/IP socket, I just mean like a socket in the abstract tool sense of where the query is actually created. In previous kind of models, your servers would be responsible for managing all of the queries and that you can actually execute against your data store, if that's a SQL database or if it's a graph database or whatever it is. What GraphQL does is it front loads that behavior in a consumable, easily digestible query language onto the front end, and then basically then enables the web apps to rapidly build queries and process responses without really requiring additional overhead or burden, and being essentially hyper optimized and efficient. And one of the nice ways is that because it just can be transmitted over any kind of mechanism, including binary protocols or HTTP or whatever you may want. It's not tied, for example, to a specific server implementation like SQL might be. So, for example, you could build queries inside a web client, or you could build queries inside a mobile app and send that query via a REST API or send it via gRPC to the backend. It's really just up to you. So anyways, there are 4 major freely available maintained packages that allow you to manipulate or deal with GraphQL in Go. I'm only going to cover the top one, which I think is probably maybe the most idiomatic and clean API. I'm not really necessarily concerned about selecting things based on performance. Honestly, I haven't really evaluated the packages for any kind of large scale performance, so I couldn't make a recommendation on one or the other. But what I find, the top one here, this GraphGopher's GraphQL Go, I really find that its API is the most idiomatic and probably the cleanest out of all the APIs. It's a little rough around the edges, but at least it's something that's usable, and that's the one that I'm going to focus on showing how to use it to build some dynamic applications. So here is a sample of using this package. I stole this directly from their example. Basically, what we are going to do is build a very simple server and test it. So given a GraphQL schema, which is here, this is basically defines the type query. The way GraphQL works, by the way, is that the top level type named query with a capital Q inside this schema actually becomes the primary query or entry point for that schema. So if there are no other types or things defined, that is the only type. And what we're basically doing here is we're defining a just essentially one edge hello that returns essentially the final endpoint of a string. Sorry, end node, not endpoint. And what we're doing here is we're just parsing the schema using our package. We're using an HTTP handler, and there's a nice built-in package called relay in the GraphQL package that basically allows you to expose this and use it just as a standard query endpoint that will plug directly into Facebook's relay, which enables, for example, using GraphQL directly in React or React Native applications or other JavaScript frameworks that use that. Going back to the query, the way that the package works is that it just uses Go reflection, but it does it in a fairly optimized way because it does it at essentially quote unquote compile time, or it does it at runtime, but it quote unquote compiles the endpoint. So it's not like it has to continually look up the value of this. So it's a one-time operation on the reflection to determine the endpoint. It maps, because of the rules of reflection in Go, requires that it needs to be an exported method. The names in the schema, which is, for example, here, need to map essentially to an uppercase one. So that is a little confusing if you're not used to it, but if you're a pretty experienced Go programmer, you can basically run it, you can basically catch on pretty quickly on the mapping rules on how this works. So basically then, just going back through real quick how this works is we're just creating a handler that's handling /query. And then we're just basically starting that using the default HTTP server implementation in Go. By the way, all of this code is already on GitHub. You can get the slides and basically build it and run it, which I'm doing here. Typically, I would do a real-time demonstration of this, but I have a lot of material to get through still, so I just take my word for it that all the code that I'm showing here tonight builds and runs, and this is the actual output here. So you would execute this using just standard HTTP. This relay handler, really all it does is it's just part of the GraphQL package, the Gophers GraphQL package that I'm using, and it just does it in a nice simple way to build an HTTP handler for you. However, as I mentioned before, the GraphQL, while it typically is used or accessed through HTTP endpoints, there is no reason why you have to do it. You could build a gRPC server and also build a handler around that and expose it as a gRPC service or anything else that you want. This is just nice because it shows you very quickly what the output would be, which is essentially this JSON data, which is this is the format of it. So you would have a data hello hello, and then this is the end node of that graph on what that value is. Okay. All right. So why is this useful? So in something like 15 lines of code, you've got a very, very quick implementation that will be able to solve or answer dynamic queries. It'll plug directly into Facebook Relay, React, React Native, any kind of JavaScript stuff. And it really just allows you to just move very, very quickly if that's the what your organization or you are trying to do as a developer. And what's really useful for this about using GraphQL in general is that it really allows front-end teams to kind of explore and experiment without requiring, significant changes on the back end. And for me as a back-end systems developer, I'm very lazy. I don't want to do any work. And if I can somehow enable my front-end teams to, go off and explore without, bothering me, then, all the better for me, I suppose. All right. So I'm now going to go through the more complicated social example that's included in Gophers, the GraphQL Gophers package. This is the right out of the box. It works. It's kind of gives you a high-level overview of how a large organization like Facebook would use it. I'm just going to go through it very quickly to really just kind of showcase the features of the GraphQL language and how they would be used with this package in Go. All right. Is this visible? Yeah. I'm gonna move that off the screen so it's a little easier. Okay. Okay. So it's a standard Go program. They have the schema here that's listed, and this is what I was referring to earlier about having a lot more features inside the GraphQL language itself. So this schema definition here basically allows you to define the top level query. There are two primary definitions on schema. This is kind of a special meta or annotation, I suppose, inside the language that just essentially shows the entry point, but you basically any type of query can be exposed directly. It doesn't have to be defined this way. They're just doing this to basically showcase how that's done. Now, basically what this is this type query is entering three types that are here, essentially admin, user, and search, that are basically can be queried at the same time. And these have parameters that are passed to that. And this here is after the colon, that's basically the return type that query would return. So an admin returns an admin, a user query returns a user, a search query returns a search result. Interface here basically shows you it's a generic shared interface. It's very similar to interfaces in Go, but much like in Java or other kind of object-oriented language, you have to basically declare a type that implements that interface. Now, what the Gophers GraphQL package does is it basically will allow you then on that query to return that value, different types that basically have that, and it will translate that into the client or marshal that into the response in the correct way that the client will be able to understand. If you're assuming that you have some experience with object-oriented programming or you understand interfaces in Go, this is probably pretty self-explanatory on how that works. They are declaring the scalar time. Inside this package, they have a special time type that marshals values back and forth between the standard Go time values, and you have to basically declare your own time type that then allows you to use it. But then you can use the actual package type, and I'll show that in just a bit. That basically allows you to use and marshal times in your queries or in your GraphQL schemas. All right, so this is pretty self-explanatory. You have a type. The thing here that you might not be aware of here is on the pagination. This is an input. This basically is listed here as a an optional input into this parameter that will allow you to page through it. It's declared this way. They've just declared it pagination. This allows you to basically reuse it as a type or a parameter, so more like a parameter type that's used for all of your various queries. But that's what the point of that is. There's also some very basic stuff like enums. Those are similar to kind of constants in Go or in, let's say, maybe a SQL database where you declare enums. And then union search result. If you're not familiar with unions, this really comes from basically the C or C++ or maybe some other kind of programming languages that you may not be familiar with. But it basically is saying that a search result is exactly the same as a user. In Go, this would be something like a type alias, but they're using the moniker union because I believe you're actually able to union multiple types in the GraphQL, schema declarations. Okay. All right. So to go through that, you can see how there's a direct correlation. So for example, on that admin, let me show you side by side. On the admin implementation, so the interface here, admin, was declared. Notice they've declared admin here as the same interface, the equivalent in Go. This ID type is a special scalar type that is built into the GraphQL language, and they have a corresponding direct type, package type that's declared as .id. Similarly, the time package, or sorry, the time type would be user declared the same. Notice here that ID, so right here, this ID here, let me just highlight that right here, are mapped the same way. That ID maps to this. So this is one of the reasons why I had mentioned I like this package more than others, is that it's actually idiomatic. So it correctly cases certain acronyms. So for example, ID, or or let's say if you had TCP or something like that, or some other acronym or some other short name, it would correctly case it in the right way that's idiomatic inside of Go, so that your interface here would match correctly. Again, we see the same issue, that the exported name needs to be correctly cased, and that's how it would work. So similarly, basically, you have a search result, and then basically the way you do this is that you have these special to functions that converts the result to the user. Where that's used, for example, is here inside the union on the search result, so that wherever a search result is returned in a query, for example, here on the search query here, the package itself will handle the marshaling or conversion of that user to the search result, since they share the same interface. Okay. The rest is relatively straightforward, not anything different. It's just using fields. You've got a contact, a user, and again, all of those various values are returned in that same way. But here's where we get to the meat of the issue, which is the resolver. I just want to show you how this is done. How you would declare this is that a resolver gets declared on, so for example, on friends is a field on user that was declared in the schema. The resolver here basically takes the param. It does this anonymous type declaration basically on all of the resolvers on implementing it, or a resolver is just basically how your queries actually get data from your backend store to the GraphQL package, which then converts it, or marshals it, I should say. But anyways, because all of the parameters are optional, they always have this kind of format. They use this anonymous type args, which is a struct, which then has the various fields declared in the order. And that basically allows you to maintain type safety even within your Go code, even if the query itself is highly dynamic. So you basically check for its existence if it's not nil, i.e., or if that's first, like i.e. if the parameter is actually first. That allows you to dynamically build the query based on that kind of dynamic information. This example is fairly complicated, so I'm going to go through it pretty quickly. I have another example that I wrote myself that gives kind of a much better idea of how to do that, but I possibly have too much content for the evening. Okay, then kind of the rest of the information inside this in this var, this user's var. This is just essentially their data store. In a real application, you of course wouldn't have it statically declared like this. You would just retrieve this from a database or some such. They're just doing this because it's an example. It's a contrived example, and hence why it doesn't necessarily work. Now we see basically how the admin resolver works. You basically get the role field and the admin stuff. So basically you can't basically convert it to that admin unless it's not that. One of the other reasons why I also like this package, even though I haven't been using it much, is that it is fully context enabled. Context, if you're not familiar with it, is kind of the accepted or idiomatic way to handle context cancellation and propagate context or query context or whatever, however you want to phrase that, between various boundaries or API boundaries inside Go, whether you're talking about internal API boundaries inside your application or between servers or something else. It's the way to do it. So these resolvers are pretty straightforward. They just pull the information from that statically declared users map or var. I mean static in the fact that it's built into the source code and not static in the runtime sense. Anyways, here on search, again, you have a search result, and this is basically filtering out the number of users based on that information. So that's just a real quick overview of this social example. This package has some really great examples, including the quote-unquote classic Star Wars example of how to do some more complex flows. All right, so let me go back to my presentation so I can move on here. Okay, so what I really like about this package that the other packages don't seem to have is the ability to parse these schemas and then use those schemas and manipulate them in ways very similar to the Go Reflect package. Now, they call this introspection. I'm not sure if they're adopting that from the kind of the standard GraphQL nomenclature, or if they're using that from some other ways. I mean, that is kind of the general term to inspect in a a query or whatever. But whatever, I kind of would have liked it if they had, I don't know, call it like intro reflect or something silly like that. But you can only ask for so much. All right. Anyways, so what I'm going to be doing in this next example is I'm going to take an arbitrary schema, and then I'm going to generate an arbitrary database schema from that dynamically, and that's kind of what you can do with the introspection. And I'm going to build up to that and show you how you get to that. So again, I just have I'm declaring scalar time here so that I can use it in my schema later. I'm just declaring a user that is a member of an organization. So an org is just basically a set of orgs, and then you've got kind of the standard fields: ID, email, name. I selectively chose to set some of them as required or not required. The exclamation means that it's required, just so I could give you a better example of how that plays out in the actual source code. And then here, of course, is our top level query. And basically all it is just a query for users. Notice that everything is required, meaning that you can't return or that your system won't return null data. So basically what I really want to show here is just how the introspection works and how simple it is. So you essentially just parse the schema. You don't actually need to specify a resolver as was done in the previous examples. But basically what you now can do is you can now loop over your parse schema types, and then you can display information about that schema. So the name, the kind, basically all of the information that the GraphQL parser was able to take from that system. And if you run that against the actual schema that I have here, you get something like this information, which shows you all of the declared types. So you can see right off the bat, there are some types that we didn't declare, but they're basically the standard JSON types: Boolean, float, int, things of that nature, until you get to here, where you get to the actual types that was declared in the schema itself, which is the org, the query, and the user. These others are kind of built-in ones that are part of the GraphQL specification, but I'm not really going to get into how those are used or what they're useful for. But what I really like here as well is that your actual query, you can get the same information about the query in the exact same way that you can about the types that have been declared. In fact, it is just a type, and it's just the query type, which is very useful, especially from a pragmatic fashion when you're trying to do dynamic code generation or things of that nature. If you're familiar at all with my XO package, I do a lot of SQL introspection and things like that. So what I'm going to do right now is I'm going to kind of do a real lame mix and match between essentially what my XO package does with, i.e. what using this introspection to actually dynamically generate the systems the queries from that, the SQL queries from that. And I'll show you how that plays together. It's a very contrived example, again, as all of these examples always are, but I'm hoping to really kind of more inspire people on what's possible and not necessarily, well, let's just put it in silly terms. It's left as an exercise for the reader. All right. Okay. Dynamic tables. So again, this is basically the same exact schema that you saw before. The only difference now is that I'm adding a parameter to basically filter out users, as well as an orgs query that allows you to filter the orgs by the name. And I'll show you basically how that comes back and what it is. Okay. So all of this code is actually in the repository. I am just getting down to the very minimal part. So I took the introspection code that was over here. Oops. I took this introspection code here and I blew it out into basically creating dynamic SQL queries to actually generate a table. So what you see here in the most insecure way to create SQL ever is to basically do a format.sprintf, creating a table based on the name that was retrieved from the inspected schema. And then basically I am getting the SQL type from that field and then essentially adding it as a column type. And then I'm actually then executing that against a SQLite database just for purposes of fun. I'll show you real quick what that output looks like. The generated SQL basically comes like this. And if you're familiar with SQL, it ends up being like this. Now, what I'm showing very simply is that this is, you are defining your SQL schema, not using SQL, but instead translating it from GraphQL or a very simple GraphQL schema into a SQL schema. This is obviously not usable, but with enough hard work and polishing, you could actually make this usable, which I've done, but not in this code base. Okay, and then this basically shows you how you would possibly work with dynamic queries. Similarly, similar to the social example on how the orgs query, or the other people queries on that social network, very simple social network implementation was defined. I am doing the same kind of resolver handler. I define it on a shared server type that collects all of the information, such as a database or whatever it might be. And then basically dynamically generating a SQL statement to retrieve that information from a database. Again, the way I'm generating this SQL is in the most insecure fashion possible. Do not do this unless you really know what you're doing or you just don't care about the security or integrity of your databases. But again, just doing this as a quick example. So I'm dynamically building the SQL query itself, executing it, appending arguments, and then here executing it against the database, and then copying the resulting rows into an array, and a slice of orgs, which is the expected return value. And voila, you have dynamically built queries based on a GraphQL schema that is simultaneously creating a schema for your database and then generating the SQL to query against it. Now, this is actually something that is very similar to, I believe, a package in Python that I've not used, but I'm aware of. It's called Join Monster, I believe. So if somebody wanted to, be clever and run that, you could do it. So here's the actual tested system. I do want to show this one more than anything else. Oops. All right. 1 second. This is the one live demo that I will do. So go build. So cat intro.go. Just oops. So this is a significantly larger implementation than the others, but I just wanted to show you that it is real code. Build -o SQLite.go. All right, so it created the requisite tables in there. The fact that it is still alive and didn't die means that it's running. Now, if I copy and paste my curl statement and execute that against the system, it should give me the same exact result, which is actually running and processing against the SQLite database. Now, just to prove that, all right, so you can couple this and use those introspections and things of that nature to basically dynamically generate anything, including running mutations and modifying tables or whatever you want. So the sky is the limit here on what you could do, especially if you start coupling with this with the dynamic properties of Go. So for example, if you're not aware, in Go, basically everything in the runtime can be dynamically generated, meaning types, values, anything, a function. You can dynamically define a function completely in runtime using the Reflect package. So you could write extremely fast, efficient resolvers that are basically parsed in from your schema, your GraphQL schema, that then queries against a combination of data stores such as Redis or a SQL database, or somebody was asking about streams, etc. earlier, and that's basically possible for anyone. And that's essentially my presentation for the evening tonight. I really didn't want to go over too much more because it's just so much information to cover. And but I'm really hoping I can encourage people to kind of go out there, learn more about how they can use GraphQL and Go. And I want to show that these technologies, even if they're originating in, let's say, the JavaScript world, they're just as usable, if not more usable, in the Go world as they are in a web browser or anywhere else for that matter. Okay, cool. So, questions, thoughts, concerns, people who want to yell at me.
Ken, thank you for the presentation. We got some questions here already, and I will show on the screen so you can read and you can answer. My rule of thumb is to use GraphQL only for read or write operations, REST for monoliths with complex business flows, and RPCs for domain-driven microservices. But would you give a different suggestion?
Sure. I mean, REST is a type of RPC, so I'm not really sure what you're driving at here. So GraphQL is a fully featured language. You can use it to do RPC instead of REST. I'm not really saying that GraphQL is better than REST. It's just different, and it might work better for your use case. I don't wake up and decide, hey, this new service, I'm going to build it in GraphQL. I mean, I would reach for gRPC or REST first. It really has nothing to do with monoliths, has nothing to do with your complex business flows. It's just a way to execute a query against the server. So that query, I didn't really get into it, but GraphQL has things like mutations. So if you were using REST, such as doing on a post or a put operation, which, and I don't really know why RPCs would be quote unquote different. I mean, RPCs are a general concept, right? Anyways, you can do read-write operations using any three of that, using RPCs, GraphQL, REST, whatever. Different suggestion, whatever works for your company. Yeah. Okay. Next question, please.
It's still from Sinta. It's also talking about decoupling. Does it require a strict decoupling between server logic and client logic to use GraphQL?
Well, I mean, that's what GraphQL does. It enables the decoupling, right? So it becomes this intermediate language that the client speaks over some kind of communication protocol, possibly a REST API, possibly some other RPC mechanism, and then the server can translate that, query into whatever backend it is. Maybe you have a complex microservices based, storage backend for where data is split across 17 different systems. But what it does is it enables the decoupling. It doesn't require a strict decoupling. Okay.
Okay. So we move to another question. It's from Boy Sandy. Also, I heard that network caching is hard when using GraphQL since we cannot caching it based on the URL. Are the only option that we have is to do it on the server by hashing the query?
Well, you're really referring to some kind of specific environment that I'm not really aware of or how it's configured. So caching could be more difficult with GraphQL for sure, because if you were using some kind of intermediate thing such as Cloudflare, or you were using some other CDN, sure, it may not be cached as easily via that proxy or that third-party service in the same way that a REST GET would be. But you can definitely do caching on the server side so that you don't have to continually to hit your database. There are a number of ways to do that. Hashing the query, yes, is one. But I would probably put an intermediate layer. This kind of depends on the scale that you're working with, but typically what I would do is that I would do everything on the server side. I wouldn't try to cache queries in a CDN or a third-party service, but what I would do is I would essentially have some kind of a caching mechanism that gets the query, sees if it's in cache. If it's not, then basically it does a round trip to the data store and then stores that in memory. And then that value would be shared across multiple servers, possibly. I've done similar things using Redis, memcached, etc. But yeah, all of that logic would have to be basically manually written in Go or some such. I mean, yeah. Sorry again, I got the echo here, so it's confusing me as I'm speaking.
Okay.
All right.
Okay, let's move. It's a question from Zaka Amar. When it comes with BFF, back-end for front-end pattern, how do you handle your GraphQL at scale when your GraphQL schema becomes bigger and too much query and mutation logics?
I'm not a GraphQL expert, so I don't really know. My strategy for managing that would be the same as managing any other large system. You know, I would just essentially divide and conquer. So if you have an extremely large schema and it's too much for one server to manage or handle, then I would try to break off a chunk and deploy that to a different server, whether you're talking about the logic or some other aspect. I don't really know what BFF, backend for front end pattern is. Never even heard that before, so I apologize. All right.
Okay. Okay, thank you, Zaka. Then we're going to move to Welly's question. GraphQL is really beneficial for separation. Each resolvers can be written to use another way to get data. What do you think? Oh, so I will just show this one. It's I think this is more complete. Building a gateway is simple.
Building a gateway. Beneficial for everyone. Sorry. Yeah, so that is one of the nice things about GraphQL is that, and specifically about the GraphQL package I showed, is that the resolvers can basically use any kind of data store or any other kind of data mechanism. So, for example, maybe you have a Redis database storing user profiles or like active user sessions, and maybe one of your resolvers retrieves from that, and then you could have another resolver return data from a conventional SQL database or something else. So it does make sense to, I guess, build a gateway out of that. But I'm not sure if you mean a gateway in some other kind of a sense. So, yeah.
Okay. Just move on to other question. It's from Hardy. Do you think it's possible to translate the GraphQL query into complex SQL queries, join likes, etc.?
Yes, absolutely. As I mentioned before, I believe there's a package in Python called Join Monster that does that. I've actually been working on something for something like a hybrid between EXO and Join Monster to basically do that inside Go, but it's nowhere near ready for release. Yeah.
Okay. Another one from Leonardo. GraphQL is cool. It can collect a lot of fields with single request. So how about security? There is user role only can accessing some fields only.
Yeah. So in your resolvers, you could basically have something like a resolver middleware chain, similar to HTTP middleware, that basically denies the request or returns empty data for if the user's role does not have access to certain data. But that's not. I didn't cover anything even similar to that tonight.
Okay. The last one. Are you still open for another question after this? We still have
Sure.
one here. Okay. It's from Roland. Is it possible to make multiple GQL servers where each handles specific domains accessible through one GQL server that can route the specific GQL server according to the requested queries or mutations?
So absolutely. I'm not sure if you're talking about just like domains as in like a, web domain, or if you're talking about just like, a domain of data. But yeah, absolutely. So one of the nice things about GraphQL, and at least about that package, is that as you can divide those resolvers up, you can basically front off those requests to, or quote unquote route them to multiple backends, right? And I assume that's what you mean by the queries or mutations. So it's, yeah, all of that logic would have to be custom written and et cetera on the front end. But otherwise, yes, absolutely, it's possible. Yeah.
Okay. I hope it can answer your question, Roland. So, is there any question for Ken here? Please write down on the comments. Okay, I would like to inform you guys. This is our meetup page for GoJakarta, and then for our Telegram groups also on Facebook. So please, if you want to join, please check it out. Right. So okay, let's go back again to comments. I think we'll have. Oh, it's from Hardy. This one. What is the package you mentioned? EXO?
Oh, yeah, it's kind of fallen out of use. I still use it, but probably is not usable by anybody who's not me. It basically generates idiomatic queries for Go against a arbitrary database schema. It's actually not a package. It's a command line app.
Okay. So I think we have the last one here. It's will Hasura replace all of this?
Don't know. Don't care. I'd rather just build my own software.
All right. So anyone have any question? No? Okay, with no more questions. So thank you so much, Ken, for your presentation tonight. And thank you for Google, also Developer Space, for our meetup today. So thank you, guys. See you again next time. Bye-bye.
Yeah. Thank you, everyone.
Thank you.